building 1,000 Starship and then find enough customers to fly each one of them 3 times a day for a decade is crazy. Welcome to this insane battle opposing the Starship and Electron rockets. Wait, what? A match between this and this? Between one of the smallest orbital launchers available on the planet and the biggest ever constructed? That sounds insane, and it is, but Elon himself said the Starship rocket would be better than even a small-sat launcher. And to find out if that's possible and how, I've picked the Electron rocket for this contest. Starship vs Electron, starting now. On my left, meet Rocket Lab's Electron rocket, 17 meters in height or 56 feet, for a diameter of 1.2 meters or 3 feet and 11 inches. With a mass of 12.5 metric tons or 27,600 pounds, it definitively belongs in the small launcher class. And on my right, approximately 7 times taller at 120 meters or 390 feet in height and a diameter of 9 meters or 30 feet, the Starship on top of its super heavy booster is one beast of a rocket, taller than any other one ever constructed. In terms of lift-off weight, the difference is even more staggering. Starship will be worth 400 Electron rockets with a mass of 5,000 tons or 11 million pounds. Let's now take a look at the payload capacity of each rocket. Rocket Lab's Electron was designed to send 200 kilograms or 440 pounds payload to a sun-synchronous orbit, but can accommodate up to 300 kilograms or 660 pounds to a regular low Earth orbit or LEO. Occasionally, a mission to another kind of orbit can be set up using the Photon kick stage and payload bus, such as the 25 kg capstone NASA mission to the Moon orbit. Still, the Starship is on another order of magnitude, sending 100 metric tons or 220,000 pounds to LEO on a single launch. Let that sink in. Starship will deliver in one trip 300 times more than Electron. The payload to GEO synchronous transfer orbit is 21 tons with a single launch. Of course, with in-orbit refueling, these 100 tons can be delivered to Mars if needed. What about the price then? What's the point in comparing a box with a box to a container ship, right? Rocket Lab Electron small rocket costs about $7.5 million to launch and is very competitive in its segment. The rocket currently is entirely expendable. There are plans to reuse the first stage, but it will mostly reduce the construction time rather than the price. Before that, Rocket Lab has spent $100 million to develop the launcher, which was an extremely low amount. If Peter Beck's company keeps its current pace of 7 launches a year, in 10 years the development cost could be as low as $1.4 million per launch, thus raising each launch cost to around $9 million. Elon Musk, on the other hand, repeatedly stated that Starship will only cost $2 million to launch, approximately half of that in fuel alone and the rest in operating costs. Starship being an entirely reusable launcher, it drives the cost down. That's crazy, right? 3 times cheaper for 300 times the payload capacity. How could these numbers be correct? Well, for once, these are not the only numbers to take into consideration. You still need to build the Starship, and it isn't cheap. According to Elon Musk, building an entirely new launcher first and second stage will cost around 4 times the price of a Falcon 9. 4 times $54 million equals $216 million. And even before that, SpaceX CEO estimated that the development phase, those SN and soon BN prototypes that we can watch fly and sometimes crash, will cost the company $2 to $3 billion. This number is actually pretty low considering the complexity of the project. SLS, NASA's moon rocket, is more or less in the same class payload-wise, and last estimates indicate a $9.1 billion bill. for development alone. Then it all depends on how often the Starship will fly. Elon Musk's plan is to build 1,000 Starships and fly them 3 times a day, every day, for 10 years. With these numbers, each Starship would fly 10,000 times, and the construction cost of $260 million would translate into only $21,000 per flight. The development cost of $3 billion divided by 10 million flights will then translate into only 30 cents per flight. The final cost of a Starship flight will then be only $2 million and 22,000. Out of this world, huh? Well, sort of. It is not only that Elon Musk's plan will need more than $200 billion investment in 10 years, but these numbers are science fiction. The hypothesis of building 1,000 Starship and then find enough customers to fly each one of them 3 times a day for a decade is crazy when you look at today's standards. For instance, SpaceX Falcon 9 is currently launching more often than any other rocket in the world, and yet only launches once a week, and mostly for SpaceX itself to grow the Starlink mega constellation. Okay, if instead of Elon's numbers, we pick only 10 Starships to be built, and 100 launches a year for 10 years, which is still optimistic, the cost then translates into an additional $5.16 million per launch, which would bring the total cost per launch to $7.16 million. Definitely not the same number, but still a game-changing innovation that will put space within human reach. Even with only 10 launches a year, the price would still be equivalent to that of a Falcon 9 for a far better capability. By the way, if that was really useful what I just shared with you, then I would love it if you would give this video a like. Just click the like button and thank you very much. Is it the end for small rocket launchers then? Times are going to get tough for sure, but a small launcher like Electron has other qualities. First, unlike Starship, it is already working and competitive against the far cheaper Falcon 9. Why? Because you don't necessarily want to send a full mega constellation all at once into orbit. Customers often want to experiment with pathfinders first. Sharing your flight with other payloads reduces the launch cost, but at the expense of often not choosing your launch date and not choosing your orbit precisely. Of course, on paper, a dedicated Starship flight will be cheaper than a small rocket. But not right from the start though. Until they have enough Starships available, SpaceX will prioritize high-value payloads over cheap smallsats and keep the benefits. What about bigger rockets like ULA's Vulcan or Blue Origin's New Glenn? That's a topic for a future video. What do you think? Will SpaceX go bankrupt trying to build the Starship, or will Elon Musk become the first king of space? Tell me your thoughts in the comments below. And don't forget to subscribe to be notified of the future match between Starship and another rocket. Here on your left is a video the YouTube algorithm has chosen for you. And on the right, you will find another videos about Starship characteristics and development. This is Getting to Space, signing off.